Hi and welcome back. Today we're going to learn all about calculations in chemistry. So this is going to take our simple mole calculations for the number of mole from mass and the number of mole using concentration and volume and applying these to chemical equations so we can work out the amount of product that we might form. We use the term stoichiometry to cover calculations in chemistry. So this is concerned with the relative amounts in mole of chemicals involved in chemical reactions. Because as we've talked about before with mole, we can't just go on mass because all the atoms have different masses. We need to know how many atoms we're reacting at a time in proportion, and the mole allows us to do that. This allows us to determine the amount of reactants that we need in order to produce a certain amount of product, which is critical if you think about if you're trying to manufacture pharmaceuticals or industrial chemicals, paints, things like that. We need to know how much we want to make and therefore work backwards to find out how much we need to react. We do this by, of course, using balanced chemical equations to give us the mole ratio, so the ratio of how much of one reactant to the next reactant will produce how much products so that we can make appropriate calculations. So we'll be talking about, say, if we were reacting HCl and sodium hydroxide, this would react in a 1:1 ratio because the coefficients on both of these would be 1. So we're going to be talking a lot about ratios. So far we've learnt lots of different equations for finding the mole of substance. We have N is equal to M on mR, where this is the mass in grams and the molar mass of the substance. Okay, we also have N is equal to C times V, where V is the volume, of course, in liters for this equation, and concentration will be in moles per liter when we're using this equation. And we also have good old N is equal to N on Na. This guy, we don't use that much. There are other equations for the mole that we'll come to as we progress through our studies in chemistry. But at the moment, these are the two that we should be familiar with using. And if we're not comfortable with those, then it's time to make a catch-up meeting and let's figure that out. So we've also learned how to write balanced equations, okay, that we can have H2SO4 reacting with 2 lots of sodium hydroxide to give us salt, which will be Na2SO4 plus water. Okay, again, a skill that by now you're expected to have and be able to do quite comfortably. So when we do stoichiometry, we need to bring those equations together with a balanced equation and work out values for the masses of different things. So for all stoichiometric calculations, we follow the same procedure. We need to, first of all, write a balanced equation. Then I want you to write the known and required information under the appropriate species. As you become more comfortable with this, this is a step that you may start to leave out, but initially I want you to do this so you can see what's going on. Then we're going to, if necessary, determine the reactant in excess. We're not doing this yet, okay? This will come later in a couple of weeks' time. We will look at this, but not yet. So we can skip this step for now, okay, because one of our reagents will always be in excess in the questions that we're going to look at for now. Then we need to determine the mole relationship or the ratio, and this must always be stated. Okay, there is always a mark for stating the mole ratio. If you don't state the ratio, then you're not going to get the mark. Okay, so you're throwing away potentially 1/3 of your marks at least every time you do this. Okay, so you've got to state the ratio, and we'll talk about different ways that we can do that. Then use the appropriate equations. N is equal to M on mR, or N is equal to C times V, to solve the problem for the quantity that we've been asked. So the rest of this video is really going to be looking at example questions. So let's get started. So this time around we've been given the equation already, but let's have a look at the question and highlight the important information. A piece of copper wire with a mass of 2.25 grams. So when I see copper wire, I'm thinking straight away copper solid, because I know that that's going to be a solid. It'll be copper, it'll be uncharged because it's in its elemental state. It has a mass of 2.25 grams and it dissolves in a solution of silver nitrate. So I'm thinking AgNO3. Remember, we need to know our valencies and be able to write these formulas comfortably at this point. Okay, so then they have given me the equation. So if they hadn't, I've already figured out the formulas. But here we see our copper wire reacting with silver nitrate to produce copper nitrate and silver solid. Single displacement reaction with copper being oxidized and silver being reduced. Next thing that it said was once we have a balanced equation, which we have, we're going to write the important information underneath each species. So that means that the information that relates to each symbol we're going to put together. So the copper had a mass of 2.25 grams. Okay, and then solution of silver nitrate, we haven't been given any information on that, so we've got no information. Okay, now let's look at what the question wants us to answer. It says, what mass of copper 2 nitrate will be produced? So this is what I'm looking for, and they want a mass of this one. And what mass of crystals of silver will be produced in this process? So they also want us to figure out the mass of this one. Okay, so this is what we're going to do. We're going to now figure out how to get across a chemical equation. We can take a journey from one point in a chemical equation to another point in a chemical equation as long as we know the mole ratio. We step down by finding the number of mole, so we want N of copper. Then we step across by stating the mole ratio, and then we step back up because that will give us N of copper nitrate. Then we step back up to our answer by using our equations that are relevant. So in this case, if we have the number of mole, we can find the mass by working out mass is going to be equal to N times mR. So let's see how that works mathematically. First things first, we need to know this is our known. Okay, we have the mass and molar mass of copper, so this is our known. I'm going to start with copper nitrate as our unknown. Okay, so the first thing I can do is work out the number of mole of copper solid. And I can work this out because I have mass, which is 2.25 grams, and I can multiply it by the molar mass, which for copper is 63.55 grams per mole. This is going to give me, when I put it into my calculator, 0.354 mole of copper. The next thing we said, so now we're down here, we've worked out this bit, we need to step across. And to step across, we need the mole ratio. So to find the mole ratio, you've heard me use this term before. We say we want to multiply by a ratio of what we want over what we know. Okay, so in this case, what we want is our unknown, which is copper nitrate, and what we know is copper. So we can say we're going to write an expression. We're going to state the mole ratio to find the number of mole of copper nitrate in terms of the number of mole of copper. So the number of mole of copper nitrate is equal to what I want. The coefficient here is 1. Divided by what I know, the coefficient here is 1, multiplied by the number of mole of what I know, which is the number of mole of copper. So now I can substitute in the values that I already have into this, and I'm going to get, they're both equal, so this is going to be 0.354 because that was my number of mole of copper. So the number of mole of copper nitrate is going to be exactly the same as the number of mole of copper. And that seems right because it's a 1:1 ratio. So from there, I am now down here. I need to step up and I want to find the mass of copper nitrate. That's what I'm looking for. And to do that, I want to multiply the number of mole by the molar mass. So first things first, I need to calculate my molar mass of copper nitrate, which is going to be equal to 63.55 plus 14 plus 3. 63 plus 14 plus 3 times 16. And I need to multiply this by 2. So let's throw that into the calculator. So 14 plus 48, and we're going to times that by 2, and then we're going to add our 63.55, and that's going to give us 187.55 grams per mole. So now N, which was 0.354, multiplied by 187.55 is going to equal 66.39 grams. So if I was to add copper into silver nitrate of this much and wait till the reaction went to completion, we would see 66.39 grams worth of copper nitrate would be produced in the solution. The second part of the question wanted us to work out the mass of pure silver crystals. Okay, so now we're going to do this. I'd like you to pause this video and have a go at working this one out for yourself, and then come back and see the solution. Hopefully you had a go. I have left our number of mole of copper here, and we're going to now find the number of mole of silver. So we've still, at this point here, we've worked out our number of mole of copper. We want our mole ratio to step across. So we're going to write, we want to find the number of mole of silver, because this is what I'm looking for, is going to be equal to what I want, which is silver, 2, over what I've got, which is my known, which is copper, multiplied by the number of mole of copper, because that's the only value I have. So in this case, that's going to be 2 times 0.354, which is going to equal 0.708 mole. So that is the number of mole of silver that will be produced. The question wants me to find the mass of silver, which is going to be the number of mole multiplied by the molar mass. I'm going to get the molar mass from the periodic table. So I will get 0.708 mole multiplied by the molar mass of silver, which is 107.9 grams per mole. And this will produce 76.39 grams of silver crystals. Okay, so you can see here we had a slightly different ratio. We had a 2:1 ratio. So it was a 2:1 for silver is to copper. So we multiplied the number of mole of copper we had by 2. Okay, so the rest of this video is going to be example questions, so it will probably get a little bit long as I talk through them. For each one, I recommend, if you're feeling confident, have a go at the question yourself and then check the answers by fast forwarding through the video. If you need a little bit more help and you want to be stepped through them, then come along with me and we'll go through each one in detail. So the next one we're looking at is a solution of lead nitrate being added to potassium iodide. And this video on the left-hand side here is going to take us through what this reaction actually looks like. It's a precipitation reaction that produces a bright yellow precipitate of lead iodide. And this time we can see that we haven't been provided the equation. So we're going to need to write the equation in order to figure this out. So as the lead nitrate is added into the potassium iodide, we see the formation of this bright yellow precipitate. So let's have a look at our important information. We have a volume here of 30 milliliters and a concentration of 65 moles per liter of our lead 2 nitrate solution. This is being added, so it's on our reactant side. So let's start with our equation. We're going to have, and it's lead 2 nitrate, so we know lead is Pb, which means we'll get 2 nitrates per every Pb, and it's added to a large volume. So this is telling me that the other one is in excess, so I don't have to worry about it. There's more than enough to allow the reaction to occur. Okay, so this is going to be aqueous plus potassium iodide. So potassium is +1, iodide is -1, and away we go to produce the precipitate. So we know it's a double displacement reaction, so we're going to get Pb, and it's 2+, so we're going to need 2 iodides for this, and that's going to be our solid of lead iodide. Okay, and then we're going to get potassium nitrate. Let's balance this out and work out what is going on in regards to our ratios. I need 2 nitrates, so I'm going to bring that over here, which means I need 2 potassiums over here, which gives me the 2 iodides that I require. So now we have our balanced equation. We're going to collect the relevant information that we need for each one underneath. So our volume here is 30 milliliters. I'm going to convert this into liters straight away, because I know I'm going to use my concentration calculation, which requires it to be in liters. Okay, and then the concentration of this is 0.675 moles per liter. The concentration of this is 0.500 moles per liter. So we're probably not going to need to know that, because if it's excess, we know we've got this in excess, we've got more than we need. And then we want to find the mass of the lead iodide is what we're looking for. So as we said before, the first thing we do is we step down by finding the number of mole. We have volume and concentration here, so we can use N is equal to C times V. So the number of mole of lead nitrate is going to be equal to the concentration times the volume, which is going to give us, when we plug this into the calculation, 0.02025 mole. So that's how much lead nitrate we have. Now we want to figure out how to step across our equation again. And as we said before, we do that by having the mole ratio. So we want to step across this way. So we're going to need the mole ratio. Okay, so we're going to write, we want to find this one. This is what I want. This is what I know. So we can see here that the number of mole of lead iodide is going to be equal to 1/1 of lead nitrate. So this means it's going to be exactly the same value, which is 0.02025, running out of space over there, mole. Okay, don't forget your units. Okay, so now we need to work out, we want to step up. Mass is going to be equal to N times mR. I have this, I can calculate this. So the molar mass of lead iodide is equal to the molar mass of lead, which is 207.2, plus 2 times the molar mass of iodine, which is 126.9, dealing with some pretty heavy atoms here. So this is going to give us 461 grams per mole. Okay, remembering our units in each step. So we can now calculate the mass of lead iodide by taking 0.02025 and multiplying by 461, and we get 9.3 grams of lead iodide will be produced. Okay, so remembering that we're multiplying, when we find the mole ratio, we multiply by that factor of what I want over what I know. And this one always be the one that gives us enough information to calculate the number of mole at the start. Okay, let's look at a couple more, this time involving some solutions calculations. So this time we're looking at our reaction with magnesium and dilute hydrochloric acid. Okay, you've done this reaction yourself when we did reactions of acids and bases. Okay, so the acid that we see on the right-hand side here is bubbling. We're giving off heat and hydrogen gas. So we're going to start with the equation, the balanced equation. We've got magnesium solid reacting with HCl gas and HCl aqueous, sorry. And we remember that this will produce a salt Magnesium is 2+, so we're going to need 2 chlorides to balance this out. Magnesium chloride plus hydrogen gas. Okay, so this means MgCl2, I'm going to need 2 HCl's to balance this out, and that will give me my H2 gas. So I have my balanced equation. Next up, we're going to collect the appropriate information under each one. So the volume of 2.3 mole per litre hydrochloric acid. So we want to find the volume. We are given a concentration, 2.30 moles per litre. Okay, and we want to now, would be required to completely consume 15 grams of magnesium. So magnesium mass is equal to 15.00 grams. Its molar mass is equal to 24.3 grams per mole, because I can get that from the periodic table. So that means I have the ability to find the number of mole of magnesium. So N of magnesium is equal to 15, my mass of magnesium, divided by the molar mass of magnesium, which is going to give me 0.617 mole. Now I want to step across. I need to do that by my mole ratio. So I want to find the number of mole of HCl, and it's going to be equal to what I want, which is 2, the coefficient of HCl, over the coefficient of magnesium, which is 1, multiplied by the number of mole of magnesium. So this means I'm going to have 2 times 0.617. I'm going to use my unrounded value to do this. So I'm going to get 1.235 mole. That's the number of mole of hydrochloric acid that is required. Okay, so I want volume, so I'm going to be using the N is equal to C times V. I'm going to rearrange for V, so I'm going to V is equal to N on C. Now that I've rearranged, I can just substitute in. So my volume is going to equal my number of mole divided by my concentration, and this is the concentration of the hydrochloric acid. So we're going to end up with 1.235 divided by 2.3, and we're going to get 0.536 litres, okay, which is quite a lot, but that's 15 grams of magnesium, which would be a lot as well. Okay, so again, I'm going to go and do our last example. You can try this one on your own. Okay, so have a go at trying this one on your own. Pause the video, then come back to see the answer. Okay, I know that this is a bit long, but hopefully you're managing to do these on your own and skip through to the end as you need, and only watching them if you're a little bit stuck. So let's start with this one. And the first things first is, of course, we're going to need a balanced equation. So pause the video and give your balanced equation. We're reacting sulfuric acid with sodium hydroxide. Okay, so remembering sulfuric acid is H2SO4. Sodium hydroxide is NaOH. So we're going to react these two. It is going to be a acid plus a base reaction. So we are going to produce a salt, which will be sodium sulfate, and water. Okay, so balance that up. I'm going to need 2 of these because I'm going to produce 2H plus from the sulfuric acid. Collect our important information together. So we want to find the volume of sodium hydroxide, and we're given the concentration. And we want to neutralize a volume of 35.5 milliliters, which is equal to 0.0355 liters of 6.06 moles per liter of sulfuric acid. So again, this is going to be my known because I have a concentration and a volume, so I can work out mole, and this is what I want to know. This is my unknown of sodium hydroxide. So let's go. We're going to work out our number of mole of sulfuric acid. which is going to be our concentration multiplied by our volume. So this is going to give us a total of 215 mole. Now that I have my mole, I can step across with my mole ratio. So let's have a look. Our mole ratio is going to be the number of mole of sodium hydroxide is equal to what I want, 2 over 1 of what I've got. So this is going to equal the number of mole of sodium hydroxide is going to equal 2 times 0.215, which is equal to 0.430 mole. And that's my number of mole of sodium hydroxide. I want to find volume of sodium hydroxide. So again, we know that N is equal to C times V. I'm going to rearrange for my volume, and I'm going to get volume is equal to N on C. When I do that, I'm going to have 0.430, which is my number of mole, divided by the concentration given in my question, 0.486. And this is going to provide me with 0.885 litres of the sodium hydroxide will be required to neutralize that amount of sulfuric acid. Okay, and that makes sense because the concentration of our sodium hydroxide is actually lower than that of our sulfuric acid, and we get 2H plus for every 1 sulfuric acid. So hopefully this has given you a bit of a chance to practice the mole a little bit. Of course, now it's time for you to have a go at these on your own and see if you can figure them out, ready to ask questions in our next class.